Welcome to PV Tech's Tech Talk webinar. This is a new series of webinars focusing on technology from the upstream to the downstream. Our webinar today is with DSM, and it's looking at retrofitting of anti-reflective coatings on modules for PV power plants. We have three presenters. The first will be Jörn Brembach. He will be the Commercial Manager of Europe for DSM, followed by Andrea Vajara, who is the Head of Technical Services and Product Management at JinkoSolar Europe. And finally, we will have Diego Molina, the Innovation Manager at Wise Energy. All three, obviously, with experience in the field of anti-reflective coatings, and particularly here, some of the studies that have been accomplished to make this a profitable, reliable, and a bankable product offering. We will be having a Q&A session at the end. So, and I'll remind people that they can ask to enter questions. We will have plenty of time to ask the three presenters anything that is interesting. Well, welcome everybody, and if Jörn is ready, we will start. Thank you, Jörn.
Thank you, Mark. Next minutes, I inform on what is DSM at a glance. You will get an insight on the reason why DSM, as the leading anti-reflective coating company globally, has commercialized a retrofit anti-reflective coating. This is a Tech Talk webinar, so we will have it a bit about the physics of technology. Next, we look at it from different stakeholder perspectives, and I will summarize with an outlook to the future. From century-old roots as the Dutch state mines, DSM has evolved into a purpose-led science company with 9 billion euros turnover, numbering 22,000 people worldwide and specializing in solutions for nutrition, health, and sustainable living. Our purpose is to create brighter lives for all. So we have this special heritage in primary energy sources, and within the DSM Innovation Center, a dedicated team named DSM Advanced Solar is now developing and commercializing innovative materials for the solar industry. Our materials portfolio can be seen here. It all started in year 2011. Now we are market leading in anti-reflective coatings for solar front glass. The installed base is already more than 76 gigawatt peak. That equals to 250 million solar panels installed in the field. In recent years, we have introduced an anti-soiling coating and came up with backsheet products as well. And last year, we fully commercialized our anti-reflective coating for aftermarket application, which is focus of today's webinar. So why should somebody make use of a retrofit anti-reflective coating in older solar parks? Here it is. I like to provide you with the big picture. First of all, old means solar parks that were installed before 2012. In this period, the market introduction of anti-reflective coating technologies happened. These solar parks now in teenager age will receive feed-in tariffs for another 10 years, but have already degraded, most time in single-digit % range. So our coating will provide a reverse effect and increase the power output by 2 to 3%. All of you can do a little conservative math with a 3% extra power output and come to the conclusion. European solar industry is leaving about 120 million euros per year on the table. This equals to almost 1 billion euro until end of feed-in tariffs. Now some words to the physics behind anti-reflection technology using a simplified illustration. Reflection in common is the change in direction of a wavefront at an interface between two media, so that the wavefront returns into the medium from which it is originated. So when light meets a solar panel surface, some of the light is reflected. The refractive index of AR is 1 compared to about 1.5 of solar cover glass. An anti-reflective coating works with a refractive index in between these two values. It provides an incoming photon with a more gradual transition from air to glass. In theory, the maximum gain in transmittance of a single layer nanoporous anti-reflective coating. So in theory, the maximum gain in transmittance of a single layer nanoporous anti-reflective coating with perpendicular light is slightly above 3%. On top of this, in outdoor conditions, there's an angular effect that can add another 1%. So the total gain in outdoor conditions can add up to around 4%. The coating structure of the DSM Retrofit anti-reflective coating is similar to our proven core shell technology for brand new solar cover glass. Our Retrofit anti-reflective coating is a nanoporous coating, 1,000 times thinner than a human hair, cures in less seconds, and of course, with a refractive index in between that of air and glass. After DSM's Retrofit anti-reflective coating is applied and cured, it is totally UV stable silica, the same substance as the glass beneath it. What makes it different is during the outdoor curing process, it creates a unique closed pore structure that is different to other coatings, where the surface roughness is much higher and a more open pore structure exists. We have granted patent on this technology, and definitely we will continue to protect our developments. Our coating has been optimized to maximize durability. We have executed all the usual IEC and internal durability tests. Our coating passes all these tests with minor changes in optical and other relevant properties. This gives us confidence that the coating will also have an excellent long-term outdoor durability. DSM has extensive experience in outdoor validation and data analysis. For our clients, parks, we have developed a stepwise process to ensure that data is gathered and analyzed to help ensure objectivity and accuracy. In the picture from a project 2.5 years ago, you see the boost in output coming from a baseline in red, right after the coating application. We are currently validating the performance of the Retrofit anti-reflective coating on string level in all our coated fields, where we compare the performance of coated modules with historical data of these strings and the strings with uncoated panels, which we call the reference. I will show you 2 other cases of megawatt peak parks later in this presentation. Now we change a bit our view and have a look at our Retrofit anti-reflective coating from operations and maintenance perspective. In the field, we provide a turnkey service. We wash the panels and spray our sol gel technology directly on the panel. Our spray coating applicator is tractor driven, which ensures a steady and outstanding fast operation. We are now still at the operation and maintenance perspective, and these O&M companies have to take care for security and that all legislation is met if they allow third parties to enter the site. DSM takes this very serious and has made its homework. Our coating product is environmental friendly, not bioaccumulative, and not persistent. Our application machinery bears a CE label. It is safely operated by our valued ecosystem partners, Stern Energy in Italy and GreenTech in Germany. For O&Ms, there's most time a good takeaway from our detailed field data analysis. In solar industry, almost all B2B decisions are made on bankability considerations. You still remember maybe the 1 billion euros opportunity from the beginning of my presentation? It is not worth anything without a reliable, trusted partner who is no startup and is there for the long term. The DSM, with a balance sheet of almost 10 billion and a proven track record in solar, provides the financial strength and bankability items for secured project payback periods, which are mainly get contracted below 3 years. Some of the bankability items we provide on product and company level are listed on this slide. Our product is in full compliance to European regulation, so it is registered under REACH. For the parks where the module warranty is still valid, we use our relationships with many module makers we have from our existing anti-reflective and anti-soiling coating business. Of course, our retrofit product is relatively new to the survived module makers, and there are different ways to deal with their module warranty. One has published an application note, others have given project-wise or general notification that the warranty is not touched by our product. In any case, we support our clients, but module makers as well, to assess our technology and demonstrate that risk to the module due to coating is inessential. An example of that process will be given by Andrea from Yinco later on in this webinar. All our activities in the solar parks are insured against direct damages, and our advanced service level agreement include a financial compensation which confirms that the cost of the coating and application will be earned back in a given time. With this, there is zero risk that the customer investment will not be paid back. Now, how does a 2.5 megawatt peak park business case look like? On the left, you see the specification of the site, 2011 park in Italy with medium irradiation and feed-in tariff. Possible 3% performance uplift on these 60 cell poly modules will lead to about 190,000 euros cash in 6 years. You can also calculate it for 5 or 10 years. We have just estimated double of a realistic payback time. Of course, the negotiated business case depends on even more site specifics and the workmanship related, but this is something we discuss with our clients bilateral. Now to an actual case from Germany. This summary here shows a relative comparison of raw daily power output data on string level. In this chart, the y-axis is the daily output of strings related to an average of carefully selected reference strings in percentage. And this is done over a long period of time. You see on the x-axis, the vertical green line in October 2019 indicates the date of the anti-reflection coating on site. The black solid horizontal line left from the vertical green line is simply the average of all these colored dots before coating. And we call it the baseline. And the black solid line on the right is showing the cumulative relative output after the coating event took place. We use this visualization to show the power output uplift. We call it the jump right after the coating application. We calculate our business cases with an overall performance gain of our retrofit coating, and the overall gain is defined as difference between the relative output of coated and reference strings. As I said, it's a solar park in Germany with first solar and two modules, and the value we achieve is significant. 4.2% extra gain creates a lot of benefit. Another fresh real-world example here. Again, it shows the relative comparison of raw daily power output data on string level over time. It's a several megawatt peak park with crystalline modules in Italy. Sometimes we just don't get data out of the monitoring systems. Then we have these white gaps you see left. From year to year, you also see that the data are more scattered during winter season. Anyway, again, a nice jump from the baseline can be observed. And the actual average gain will lead in this case to a 2 years payback time, which is, I think, outstanding compared to other refurbishment solutions on the market. Let me close my part of the presentation session with an outlook. Our DSM Retrofit anti-reflective coating is fully commercial in Europe. Coating season 2020 is right there. We will process our multi-megawatt peak project pipeline and are ready for high volumes. Of course, we will continuously provide service and bankability improvements. That's never a standstill. We are aiming to commercialize in overseas in 2020 with selected partners who are willing to invest in the equipment and who are willing to set up a dedicated team for execution of the application. All right, with this, back to you, Mark.
Thank you very much, Jörn. And our second presentation is from Andrea Viaro, Jinko Solar's Head of Technical Service and Product Management in Europe. So hopefully, Andrea, we are good to go.
Yes, Mark. So as Jörn was presenting, and thanks to Jörn for your introduction also, and thanks for the opportunity that DSM gave us as Jinko to participate to these module assessments and evaluation of the DSM ARC treatment for the PV modules to improve the performance of the modules. It's something that we always are pleased to achieve, of course, and we were happy to participate with DSM on the definition of the tests and analysis of the modules to make sure that the coating does have positive impact not only on performance of the modules but also on the reliability of the modules, that does not influences in any possible way both performance and reliability of the modules, as I said. So to confirm that the warranty ultimately is not affected either, because that's the in the end of the day the possible concern of investors or customers, asset owners that might want to use this coating. Is that the reason why we were very happy to partner up with DSM to do this evaluation, to make sure that modules do not have any mismatches induced by this coating, possible inhomogeneity, which might cause hotspots that could somehow affect the module performance and reliability. So we designed together with DSM a test site which was prepared at DSM test facility on the rooftop of DSM facility. It's in parallel on the same rack, so as to have similar irradiance and working conditions, basically, to compare them equally. Also, of course, weather conditions were measured to control the operation conditions of the modules, and we managed, fortunately, to put the modules and to analyze the modules in conditions very similar to STC, fortunately. We kept the modules for a little more than a month, 42 days exposed, also to evaluate if the stability of the DSM coating was durable in the initial phase of the operation. And in terms of measurements, we controlled not only the current and operation activity of the modules, but not in terms of performance, but in terms of temperature and thermal behavior of the modules through infrared camera scanning and temperature measurements on individual cells to compare the different operations and conditions of the modules. So as I said, we didn't focus on power measurements or performance measurements, which was the topics addressed mostly by Jörn in his presentation before, showing how actually it's beneficial, this step up or jump in performance of the modules. The scope of this analysis was purely on reliability and comparing modules treated differently to have an evaluation of possible, as I said, mismatches or differences in temperature and thermal behavior of the modules because of the induced or simulated non-homogeneous coating on the modules. So we designed an array of modules with different conditions. We used one coated module as a reference one on top of the array here, one fully covered module, fully coated modules, and then one other module with one string of cells not coated and two strings of cells coated, strings connected to the bypass diodes. I will show you later why. And then one other module coated and not coated vertically. So the top part is not coated, for instance, and the bottom part is coated with the DSM ARC retrofit coating. And the last case scenario was the worst that we estimated, having basically a few cells highlighted here by the red dot, not coated. which might act as bottlenecks for current. Therefore, in theory, if there is any mismatches at that level, induce hotspots and be visible through the thermal camera or infrared or temperature measurements shown later on in the slides. These analyses and these scenarios were defined because, as we know, modules have series connections in cells. So all the cells are connected one after the other in series, which means that any bottleneck for current might be a trigger point for hotspots. And that's the reason why we have bypass diodes at in parallel connection with the 3 substrings of cells that we have highlighted here in the green boxes. So it's 1, 2, and 3 portions of modules, which are almost operating separately and somehow connected to the bypass diodes to protect them in case of hotspots. And just to anticipate something, clearly we didn't see this scenario happening. So now actually diodes were not activated, fortunately, because the hotspots in the end were really almost not visible or negligible, really not related to the temperature coefficient, temperature differences of different coated modules. So as I said, modules were kept for a little time on the rooftop test site, about a month and a half, to evaluate the module coating stability. The measurements were done around noontime, so having almost stable irradiance level throughout the measurements that were performed, very similar to STC conditions. We were at about 20 degrees Celsius ambient temperature and around 1,000 watts per square meter irradiance. Not only temperature measurements, as I said, were taken, but also ampere current measurements of the modules, because each of them was connected to a single MPPT, and through the monitoring system was possible to measure the operating current of the single modules to compare one to the other. So we see in this chart summarize the measurements taken on irradiance, temperature, and current, respectively, on the blue line, yellow line, and red one, orange. We see that the variations on the temperature of the modules and cells is mostly related, or almost exclusively related, to the variations in irradiance. Clearly, we know that when irradiance changes, of course, not only current or power of modules changes, but also the operating temperature of the module changes accordingly. And that's exactly what is shown in this chart. Really, visually, the trend of the 3 lines is following the same variation trends according to the irradiance variation. That is also visible in the next slides in the summary and the table here of the single cell temperature measurements. The red highlighted cells in the bottom right part of the chart here is highlighting the cells that were measured with the thermometer, infrared thermometer. We see that there is a variation in current of the module, operating current of the module, because it's related exactly one-to-one to the irradiance level, which is ranging from around 900 watts per meter and then 950, and then a little above 1,000 watts per square meter, which is the main cause of the difference in temperature that we have here on the average values, because we see that it's following the same increasing trends that we have on the current, as I mentioned before. And in terms of scenario, this is the scenario with the uncoated cell string connected to the first diode here, which is compared to the other 2 string cells which are coated with the DSM treatment connected to the second and the third diode. So the approach here was to compare the 3 strings of cells to see if there was any mismatches in temperature and current here, which, as I said, was really not detectable, and confirming our hypothesis on the completely stable behavior of the modules. We present now here only the other worst case scenario that we designed of the single cells not coated compared to the rest of the module coated. We see that there is the few cells, 2 cells per cell string uncoated, which in principle, if there is any current mismatch or irradiance mismatch, they should act as a bottleneck for current and triggering hotspots. This is not the case, fortunately. as shown here also in the table, also because the irradiance level was rather stable throughout all the measurements of the cell groups. And fortunately, we were able to measure almost the same temperature on all the group of cells, confirming the fact that all the cells are operating at the same temperature, at the same current mostly, and of course, because of the series connection, but not highlighting any temperature mismatch because of the different light absorption given by the different transparency or reflections of the glass. So concluding the first part about temperature measurements, we can confirm that there is no mismatches in temperature and not visible on the temperature measurements that were taken from the modules. The modules are operating at really stable temperature. All the cells are at homogeneous temperature mostly. The differences in temperature are at the lower level, lower part of the range, which is the detectable differences of a few degrees for temperature differences of PV modules, which are normally happening even in normal conditions when modules are, of course, not treated necessarily with any extra coating or special conditions. The differences are really negligible, and also that's the same confirmed on the infrared scanning analysis. We see that the thermal pattern of the modules is completely homogeneous. These are the cases of the uncoated modules on the left-hand side and fully coated modules on the right-hand side. We see that there is, of course, clearly in this case, a homogeneous thermal pattern on the modules, no hotspots highlighted, and it's rather visible at the same time the light reflections because of the sky, not uniform conditions, not perfectly uniform condition. The few clouds that were passing by, of course, were reflected on the glass, giving these apparent hotspots, but it's just a different reflection of the glass, not a real thermal behavior difference of cells on the PV modules. So confirming that the modules are operating in a very homogeneous way. In this chart, I'll also summarize the thermal images, the infrared images of the main three scenarios that we analyzed. The first one with the vertical cell string not coated and two coated. The second case in the center with the top part not coated and the bottom part coated, which is critical also to see whether there is any temperature mismatches between the top part and bottom part, which was not clearly the case. And the worst case scenario with a few cells uncoated, highlighted here in the square boxes, we see that there is a slight dishomogeneous temperature apparently here, but it's mainly caused by the different reflection level of the glass, thanks to the fact that the part coated with the DSM Retrofit coating is absorbing more light, letting more light through. Therefore, the apparent reflections of the light on the surface of the glass is apparently different, giving this aberration on the apparent temperature difference that we have. But it's clearly not a real different operating temperature of the cells. So concluding from our side, of course, we wanted to confirm that modules, even in unlikely conditions where the retrofit coating might be not homogeneous for whatever reason, or for different aging of the surface coating on the modules, might not have any negative impact on module reliability, inducing no hotspots, which are also confirmed in this analysis, not even detectable by thermal camera analysis or infrared thermometer analysis. And we were happy to confirm that, of course, the reliability and not only the performance of the modules are perfectly in line with what we expect, and positively impacted in both cases by the retrofit coating from DSM. And of course, in this case, we could confirm that the validity of the either product and power warranty on the modules were kept intact, valid, and actually happy to see that the modules can, even though with previous old technologies without anti-recycling coating on the glass, were improving their performance, and of course increasing benefit for the investors and the asset owners also in this case. Thank you very much. Back to you, Mark.
Thank you very much, Andrea. Just before we go to our final presentation, we have just another quick poll that we would like to conduct. And this is really, do you think DSM's retrofit anti-reflective coating could be a good solution for some of your PV power plant assets? Obviously, yes, no, perhaps, or it's simply not applicable. If you could just give us some insight there, that'd be great. And the results are that yes, in fact, 30% have said yes, only 4% have said no, and there's a middle ground about 42% with perhaps, and just 24% with not applicable. Thank you very much for that. Our final presentation comes from Diego Molina. He's the Innovation Manager at Wise Energy. And if Diego is ready, please start. Thank you.
Yeah, thank you, Mark, for your presentation, and DSM for the opportunity of presenting our asset management perspective in retrofit anti-reflective coating. We will see briefly the Wise Energy history and why we were interested in retrofit anti-reflective coating and our experience on that, and how we can mitigate the main concern of the owner and give them a different solution. Wise Energy is a global solar asset operator. We are in the solar industry for more than 11 years, and we have a good track record to increase the value of the investment of our clients, following three main steps. That is increasing the revenue and the yield of the assets, and minimize the business and operational risk, and maximizing the profit of our clients. We are currently managing around 1,500 plants for 4 billion euro asset under our management. We grew up during this year internationally, coming from Italy in 2008, going to UK in 2014, and expanding in India, in Africa, and in US market last year. And we are planning to expand our presence in Central and South America during this year, in Asia, and increase our market share in European market. Why we were interested in the retrofit anti-reflective coating is everything come up from our philosophy that you've seen before. We had a dedicated team that bring to our clients the best service and a new technical solution. Anti-reflective coating is a peculiar optimization, is a really step aside from the traditional revamping situation of modules or revamping of inverter. And so we can do the difference with our experiences and with our knowledge in translating the opportunity to our clients. And most of all, we were interested because it's a really great opportunity for our customer that cannot leave on the table, as we've seen before. This is our experiences. We start with scouting the technology in 2015. We accelerated during that year in understanding how everything works. And in 2017, we had a lot of steps. We have a collaboration from my professor from Polytechnic of Milan, and we had 3 different tests on 3 different suppliers during that year, and we had also the first DSM meeting. It went well. What was really good meeting. In fact, the 2018 we had the first pilot test on around the 70 kilowatt peak. And from that time, the results are very good. In fact, last year we had the first productivity project around 1.7 megawatt capacity, and we are currently managing the coating operation of a productivity project on around 8.3 megawatt capacity plants. And we have plenty of prospective project with very different owner in our pipeline for this year. Due to our knowledge of the different customer, we have find out a lot of some concern, and usually we bring a different solution to solve it. The first one that we would like to underline is the operation on field. we usually try to manage the health and safety, and we do our best to project management all the stakeholders, not only DSM but also the O&M, every subcontractor involved. And mainly we do a site visit to control the standardized operation of the DSM. Another point that we'd like to underline is about the warranties of the modules, or the PV modules. We open up a collaboration with DSM and main module supplier in order to find a solution to maintain the warranties even after the coating application. The third point is very important, is the measurement of the coating performances. We think that our third-part view, with our statistical analysis on the results, we can effectively measure the gain, or the jump, as Jörn said before. And we usually design the project itself following the specific electrical configuration of the plants in order to effectively measure the gain. A fourth point is about the warranties of the O&M contract. Again, we open up an open collaboration with all stakeholders and sharing the methodology of measuring the gain of the coating, and in order to discount this gain from their performance contract available in that project. So, coming to a conclusion, with our knowledge and with our experience, we started a trusted collaboration with DSM that is built on the confidence on the technicality of the retrofitting anti-reflective coating. And we think that a third point of view of an asset management that could make everything more easy for the clients to catch the opportunity of the anti-reflective coating. Thank you for the attention, and I give everything back to Mark.
Thank you very much, Diego. Just wanted to remind everybody, if we're getting a lot of questions coming in, we will start the Q&A very shortly. But if you've got any questions, please add them now so that I can look at seeing how many we can collate together to the audience. While I'll give people a few seconds to think of any further questions, I'd like to do our final quick poll. So it looks like with the poll said, how would you compare DSM's turnkey solution to other retrofit repowering options in terms of economics? Obviously 29% believe that it would be better performing, 9% equally performing, 4% just said it was worse performing. There's obviously a lot of people that are not sure yet as to what the actual solution can definitely provide for people. So we've been collating questions. I want to start off, if I can ask Jörn, could you just describe to people the way in which the coating, what are the conditions for the anti-reflective coatings to be deposited in the field? Several people were concerned about, is this from a heat perspective? Is there a temperature? It has to be done at a right temperature. Also, related to that is actually the yield. How durable is this coating over the long term? So perhaps you may be able to answer those two aspects.
Yes, I can do that. It's actually a very good question. Generally speaking, our coating is applied in a coating season. Starts from April, lasts till November in Middle Europe under normal condition. And composition is made for a certain range of outdoor parameters. But yeah, that's part of our outdoor application know-how. We serve our clients with a talented field service engineer who constantly measure the parameters And yeah, you can also compare our coating with a very thin paint that contains a solvent which evaporates. But yeah, we can't disclose details on how this is achieved and also the temperature range. But Middle Europe under normal outdoor conditions is always possible. And to the durability, our coating has been optimized to maximize durability. The coating, as I said, comprises an inorganic silica-based network, which is intrinsically UV stable. And we have executed all these IEC 61215 tests like damp heat and humidity freeze and internal durability tests, also extended ones. And yeah, as I said, our coating passes all these tests. And this gives us confidence that the coating has an excellent long-term outdoor durability. However, we can't and don't want to put a hard number to this. The platform technology, which is already 10 years in the market, has in all these years never had a complaint regarding significant degradation or negative performance of the anti-reflective coating. So once again, we are pretty sure that it's that it has a very good durability. Back to you, Mark.
Yeah, thank you for that, Jörn. Back to you again, actually, summing up some of these questions. Obviously, does DSM work with other module manufacturers, not just Jinko Solar? And also, do you have any plans to introduce the anti-reflective coating product in, say, markets like North America?
Yeah, as I said, we have some plans, and yeah, we are looking for partners. But yeah, we don't state any details on our plans. That's also bilateral talks. But if the one who has asked this question can come up to me, then yeah, we can do this discussion together. And yeah, for the other module makers, it's clear the parks almost contain different panels each time, and a lot of these old modules are from yeah, module makers that have disappeared. Then also the warranty is not an issue. But if not, then yeah, we get in touch with we have a lot of contacts to these tier 1 module makers who have survived, and we help our clients to yeah, get all the question answered which may come up.
And you're not dictated by, say, Jinko Solar. It's not exclusive with Jinko Solar modules. It's just that my assumption is that Jinko Solar client wanted this, and they've obviously worked very closely with the client to enable one, to dispel any challenge issues to do with the warranty, but also understand that this is being done to had any anti-reflective coating on them before.
Yes, yes, it's yeah. We estimate that globally, yeah, about 90 gigawatt peak is uncoated, and in theory, everything can be coated by our coating. It's fully commercially, and yeah, as I said, we have dealt with several module makers in the past, and also during the coating season 2020, we come up with other corporations.
Excellent. Okay, we have with the when the coat, obviously, one of the questions here is asking about gives a little bit more detail about how the coating doesn't hurt, or the payback side of things, but you don't go into the detail of how it actually works. Is it just reducing? I don't know what the quite spelling of this, but I think what they're trying to express is that things like the toxicity, you know, what's the relation, what's the challenge there? What is also, is there, you know, there isn't the sort of the coating aspect of this is how long does it take? How long does the coating last from a lifetime perspective? There's also the issue about that, you know, this 3%, does that degrade over time? So that if you get the 3% boost, does that degrade over? Is it actually, because I think you're showing sort of winter testing, but actually does that improve in the summer months? These are several questions combined there for you, Jörn.
Yeah. Yeah, maybe refer to these gain. The gain is not a hard number, and our data analysis is always ongoing. So you have seasonal effects like this scattering during winter times, and also influence from the measurement uncertainties and from the site itself, soiling, and so on. So of course, longer observation period adds even more value to the statistic, but we are curious people here at DSM and want to see it from day one, and also our clients want to see updates after a certain period. Our coating is non-corrosive. You have seen in the Inco presentation, it causes no hot spots, and it does not change isolation values or whatsoever. So DSM has also executed a risk analysis regarding the potential effect of the coating on the module and its components. And the conclusion is that the risk of degradation of the module due to the coating is negligible. And a formal statement is also available under NDA.
Excellent. I think we've got time maybe for just one more question. Obviously, because the anti-reflective coating is done in the field, is there? Does it have to be done on a dry day? Is it got to be a certain temperature range? People were just trying to understand, you know, are there any sort of application restrictions as to when? Because obviously, if you've got a large PV power plant, it's not just done in 10 minutes. So from an environment, you know, the environment at the time, what are the conditions that you have to have or are actually not relevant?
A major factor is that these panels need to be thoroughly cleaned to remove all soiling and dirt. And that's done with utilizing standard panel cleaning methods. So a lot of DI water and brush systems. And the temperature, as I said, is something which we consider as know-how. But of course, the coating cannot take place during raining. That's clear. But after a short period, the coating has dried out, and it's no problem that it rains afterwards. Yeah. And some other parameters for the application we also don't want to comment in public.
Okay, but other than rain, it's pretty much robust to be able to done in, you know, even in the cold winter.
Yes, it's an outdoor application. It's there to last for a long term. Snow is not a problem. Freezing is not a problem. Actually, it's a very thin layer of glass which is on the module surface after we have coated it. So there's no major difference to the front glass, which is already there.
Well, looking at the time, I think we've done well. We're going to finish as expected. Just wanted to send my own thanks to our three presenters today. Webinars are one of those things that these things do happen from time to time. But and also thank you very much for everybody that has attended this webinar, and we look forward to speaking to you again and having you guys back at some stage in the future with our Tech Talk series. So Once again, thank you all very much. Goodbye.